I wanted to share this project with you people. I believe that okay, but the thing is you have to do this project seriously. Okay, you are good to see my screen, right?
Yes, Anamika.
You people can speak.
Yes, we can see.
I believe that you are good to hear me and you are good to see my screen as well.
Yeah, Anamika.
Om Prakash, you are on mute.
Yeah, we are able to see.
Okay, so this is one of the project for the JSON data. JSON data where you want to extract the data with its transform with some complex transformation. Okay, so where you have to process the JSON data by transforming nested structure into a flat format and extracting relevant metadata and standardize the date formats for the further analysis. Just let me verify something else. Okay, yeah, this is fine. So here you have two things to do. Means the same data you have to get into the two types of output format. What is the objective of this? This JSON will be very nested in the real time. We are going to get the same. In the real time, most of the time you will be having nested JSON and you have to deal with that, right? So this is transforming nested JSON, convert complex nested JSON structure into a simpler flat format to facilitate easier data processing. Then extract metadata. So retrieve and clean file metadata including names and dates from JSON and file paths. Then standardize the dates. Convert various date formats to a consistent UTC format. UTC format is always good because we are working as a global team member and we are having multiple different timestamps in the data. If let's say you are working with 4 different country data, then there can be some different timestamp, time zones and all. So why not to get it as a universal one, UTC, right? Then what you need to do? You need to flatten JSON data, then extract and clean the metadata and convert the dates doing the ETL to apply the transformation and then data integration. That data integration you can do either if you have set up the Kafka already, then you can work with the data and then you can push the data to Kafka topic. Or if you have the SQL, then simply you can first push the data to the SQL, then build a data pipeline, read from the SQL, do the transformation, run your Spark application, and then push the data back to Kafka topic, build a proper data pipeline. Okay. Then what is the expectation for this? You have input and you have output. Input should be nested JSON strings with the complex structure and file path for the extracting file names and the dates and then date strings in the various format. Output will be flattened nested JSON with the simplified structure, then cleaned file names and extracted dates, and then dates converted to a consistent UTC format. Then next come to this data summary of the input. Here for the as I said you have to this is mostly for flattening the nested JSON. So flattening nested JSON where you have to output should be flattened nest JSON with hierarchical key. You have to get the hierarchical key. Then extracting file name from the file path. Then clean the file name and extract the date from the file name and then standardize the date format and the cleaning attributes and values. If data is having some issue, then do the cleanup. Then from here, we are going to start how many columns you are going to get in the output. First column will be parent ID, then item ID, then file name, and then collection date UTC and the target object class instance, relation tree, attribute value, and attribute name. As of now, this looks very complex. Okay, so before explaining all these things, I will be going directly to the data that will make your job easy. So this is the data. Let me open that first with Notepad. Or let me copy this itself. So this is the data. Okay. If you see, this is the root test log. Then you have test, and test is starting here and ending here. You can see data type, then test info, then test version. This is one description. In description, you can see here it is wrong. 2 stars are there, one minus hyphen is there. That is wrong. It should not be. So it should be cleaned up. Okay. If this any kind of uh, special characters are there in the word or sentences in the value section, you can take care of that. And then here you can see hardware info. This is one of the another attribute. You have hardware info, then revision, then file creation date time. Here if you see data date and file creation date time. So what is happening? Let's say whenever file is getting created, that time uh, that time is different. And well, maybe when this what is the data for the date for the data, that can be different. Okay. So in the code, what you have to do, you have to check if this data rate is available, then take this data. If this data rate is not available, then take this data. So just I will explain that later. Here if you see the time zone is different. Here it is plus 5:30, here it is plus 6:30. So now you can convert that to UTC. Then monitor. This is the monitor data, monitor type, then hardware info, model name, index. Then you have disk. Disk is a list of the JSON. Here if you see, this is the disk, and disk is having let me max in the maximize. You can see here, this is the disk one. This is disk one from here to here. And then inside the disk you have partition. So for partition, this is the partition. You have partition 1, partition 2, and partition 3. So this kind of data you have. Okay, you have nested data with array, list, and all. And then accordingly you have processor. Here is the processor. Processor also list of the processor. This is processor 1, this is processor 2, this is processor 3, and this is processor 4. So accordingly you have to flatten this JSON. How you can do that? Let me go to the output, then I will explain each and everything. This is the input, and you whenever you are working with this, you are saving the file, then save in this format. Okay. So whenever you are saving in this format, you can extract the timestamp from here as well. This one. Now going to next. This is the output. So let me expand the output. If you see here, what I have tried to get. I have created one of the parent ID. Parent ID, if you see, this is very common for each of the row. Why common? Because I have taken parent ID means unique ID for each of the file. For a single file, these many rows are there. Okay. For each of the key and value, you can see there is a one row. Data type, test info, test version. If you see from here, you have data type, test info, test version. So for each, we have one of the row. This belong to one file. We can have multiple files, right? So how you will understand that this data belongs to which file? Because of that, we can have a parent ID, and for each of the file, we can have unique parent ID. So that will be helping to identify that this data belongs to which file. So this parent ID will be unique file as per file level. Then you have item ID. Item ID, you can see this is the unique number. You will not see the duplicate. So item ID is unique for each of the parent ID. Like for the parent ID, okay, how many item IDs are there? There can be item ID can be duplicate for the different parent ID, but inside one parent ID, this will be there will not be any duplicate. This is the dynamically generated number just for the reference of the project to making sure that it's consistent and you are making it you are making sure that how you will be working with the data, how you will make sure that this data belongs to this. If you want to have some reference, how you will be getting it. Then file name. This file name I have extracted from this file name itself. This is the file name. So you can have some file name. I have just extracted this name. Okay. And output. So this is the file name. Then collection date UTC. So collection date UTC, we are going to generate it. How you are going to do that? Here is the logic for this. So here I will copy this as well. This is the file name. Uh, Here if you see collection date, first you have to check extract the data date from the file. If data date is available, then take that. If you go to the file, you have data date. If that is available, then take this date. Then if that is not available, then if that is missing, then take this one, file creation date time. This one. This is available in the in this JSON. You can see file creation date time. This one. And finally, if this is also not available, let's say this both are missing from the JSON. Then you have the file name here, right? Here you have the file name, and in file name you have the timestamp. So take timestamp from this one. So first you check both of the attributes in the JSON. If that is available, first one is available, then take first one. If not available, then take second one. If that is also not available, then extract the timestamp from the file name and then convert to the UTC in the expected format of YYMMDD with hyphen. Okay, and then get this column data. Then target object class. Target object class in the sense from where this is going to be. So this is the relation tree. Relation tree I can explain you for the data type what is the relation tree. So see this. I will just minimize it. And you can see here for the data type. This is the data type. So for this data type relation tree is test log and then test, and inside test this data type is right. So this is the parent, then this is the child, and these are the child of this. So this is the relation tree. Now coming to this this one, row number 7. So for this row number 7, here you can see hardware info ID. So this is hardware info ID here. Who is the parent for this? Parent for this is test log, and then test log, inside test log you have hardware info. This test and hardware info is siblings. Okay, but parent is this one. This is the parent of this also, and this is the parent of this also. So here you are maintaining the relation tree. Test log, then hardware info, and then this is the attribute name. Okay, and then this is the attribute value. Accordingly, coming to monitor, if you go to the line number 11, this is row number 11. So for monitor, what is the relation tree? Monitor is the child of this hardware info. Okay. Test is getting ended here, but hardware info is getting ended at the last. So monitor is the part of that. That means monitor is having parent, that is hardware info, and hardware is also having a parent. So for monitor, if you see a test log, then a hardware info and then monitor. So this is the parent, and inside monitor you have 4. Monitor type, then hardware info, then model number, model name, and then index. For each, you can see here the row: monitor type, hardware info ID, model name, and index. Then coming to disk. For disk, if you see here, it is giving the same parent. This relation tree, test log, then hardware info, then inside hardware info you have disk, and then you have partition. But you are getting disk 1 and partition 1. Why this is? Because we are giving the indexing to understand that this data belongs to which disk. Here, if you see the data, you have 2 disks. This is 1 disk. I will minimize it. And then you have another disk. This is okay. Here your disk is getting ended. Means disk is a list, and disk is having 2 disks. This is 1 and this is 2. So for both the disk, you are having here the data you can see. Inside the disk also, you have partition. So inside the disk number 2, this is the disk number 2, you have a single partition here. So if I go here, then I can show you. For disk number 2, you have one partition only. So we are not giving any number, any indexing number, because if single number, then indexing is not required. But for disk number 1, there are 4 disks. So 3 disks. So the indexing is required 1, 2, 3. So that we will be having the understanding that this data belong to which disk. So let me expand this one. So this is partition. Partition 1, hardware info ID, then disk ID, then index, then size MB, then name. Okay. Then again disk 2, sorry, partition 2. So partition 2 also having the attribute name is same, value can be different. So accordingly I'm giving the number. And here for this column, if you see, data is getting derived from the relation tree only. Okay, this is the data hardware info ID. This hardware info ID belongs to partition 1, that you can extract from this relation tree. And this partition 1 is the main root for this partition 1 is partition, because partition is having partition 1, 2, 3, 4, and all. Okay, so like this you have to extract. You have to extract all the key value, then its relation tree, parent to child, have the indexing if that is list or array kind of, and then get accordingly its instance class and object class. Object class is the main class. Instance is if it is having any instance. Okay, for that one. So here if accordingly disk 2. This is the disk 1 data where you can see idle time, then hardware info ID. If you go here, disk 1. This is disk 1. Okay, in disk 1 you can see idle time, hardware info ID, and all. So accordingly you have to convert this complex data with its relation tree into this tabular format. This is one of the requirement where you have to create this parent ID. Parent ID means that will be unique ID for the file. Here I am giving you one sample file. You can have 10 file, 100 file, 1000 file. So for each of the file, if you are generating that many records, finally how you will be understanding that this data belong to which file. Then you can have unique ID for each of the file. Then this is the item ID. Item ID I created unique for the file level. Means a row level for the file. So this parent ID is unique for the file level, and this item ID is unique for the row level for the file. Then this is the file name I extracted from the file name input. This is the UTC timestamp. UTC timestamp. I believe that you understood how we need to do it. We simply need to check the field if that is available. Like here we have, let me just repeat it. So you have three options. It will be above. So for I have given all the mapping what you have to do for each of the column. Like this is if you start from here, parent ID, then mapping logic generate a unique ID at the file level using a fixed 9 digit. You can have any digit. Here I am giving 9 digit. Item ID generate a unique ID at the row level using a 9 digit random number. Then file name directly map to the input file name, whatever file name you have given. Then collection date UTC. For that you have three things. One, primary source you will be checking in the loop, means in your function, if this data rate is available. If it is available, then don't check for the next, just return this date with the UTC format. Then secondary source, if this data is, if this field is missing from the JSON, then look out for this one and do the same with this timestamp. If this is also missing, then finally take the timestamp from the file name. In file name, we have timestamp included with the file name, extract and then convert into the expected format. So like that, you have to do that. Then for the target object class and target object class instance, as we shown in the output, relation tree, I believe that you have understanding. The relation tree means all the parents and sub means parents about parents and who is the parent of that, like that, all the complete relation hierarchy level. It has to capture all the things. Then attribute name and attribute value, this is the final what is the attribute name and what is the attribute value. So that you can extract. And here this is just for the example, but actual example I have already mentioned in the Excel sheet that is attached in this document. Okay. And you have to extract the exact output with these columns: parent ID, item ID, file name, collection date, UTC, and all these things. Then next you have to work with the same data, but output model will be different, because let's say this is structured, that your output is going to be converted into the structure format, a tabular format. And if you want to store in any of the table, let's say either your SQL table or Hive and all, then you can do that. But if you are working with no SQL database, then what you will do? So for that, this is the use case. Okay. So split each nested JSON and store it separately in any NoSQL data with its metadata details. Okay, for each child node, it will be having a splitted separate JSON, and all attributes should be filtered out if its value is null or blank. If any attribute is there, if its value is null or blank, then just filter it out. That is just a use case. Then this is how you have to get the output. Here you can see logic is same. Whatever logic we have implemented, that would be same. Only the thing is storage format is different. There you were storing as a tabular format because you are going to work with the structured data set with any of the relational database. And here you are going to work with the NoSQL database. Let's say your stuff, your target is Kafka topic or MongoDB, or if you are working with cloud, then maybe in Azure you are working with Cosmos DB, in AWS we are working with Dynamo and all. So if you are having different sources, then your output model will be also different. So let's assume that you are working with that kind of targets where you cannot push the data into the structure format. Then this is what you are going to do. So you are converting the each of the record as a JSON. Okay, and not each of the record. This is for the domain wise. So here item ID, then processor. For processor, you are capturing the entire data. That means average frequency, then max frequency, then minimum frequency. So in if you go here for the processor, if you see this is having index and minimum frequency, maximum, average. You are having four. So all four are captured as a single JSON. Again, so this belongs to processor number one. Then again for processor two, this all will be captured into a single one. That means for four processor, you will be having four JSON document. Okay. If you come here, you can see this. So this is the one. Then relation tree also captured here. This is the collection date UTC, whatever you converted the date format. Then file path, input file path, whatever you have, you can have. Then object class instance, then object class parent ID, item ID, everything you are going to maintain here. And then if you split that as that output, then these many JSONs you are going to get as output for each of the module, for each of the domain. You will be having one. Like if you look out for the processor, then for processor, let me just search. Let me find it. Okay, so this is where again again one time. So total four time it should be. Okay, so like that, like for disk we had two times. So let me search that disk. Do we not have disk? Okay, we have disk here. So this is the disk, and for this disk, this is capturing for first disk. Then you will be having the second one, and accordingly, it will be uh, processing all the things. This is for disk 2. If you see here, object class instance, this is disk 2, and this is the relation to. So likewise, you have to take this input data and create data. Means do properly pure Python code with PySpark. Okay, make the source and sink both. Source you can take either as a file directly or take from the database. Sink you can try to for the structured data you can push the data into the SQL table, and for unstructured this same structure whatever you are converting into this JSON format, that you can try to push into MongoDB or Kafka topic as your output format. Okay, and try to do this with proper coding, proper function, and not in a kind of rough that okay you are just doing the rough thing. No, do this properly. You can take 1 week, and then you can give me any date, either in next Thursday or Friday, and we can have review whoever had it and what you are going to do, how you have did it. And if you will be doing this, then that is going to be helpful more. And this is a real time project. Okay, this is a real time project, and you will be learning a lot whenever you are working with this, because you will be getting the things how you are going to handle the nested and complex kind of data, and how you are going to define all the things. So in this document I have tried to explain all the things. Just to go through this and see if you have any challenges or any issues. So today I will be sharing the exercise for that Spark streaming, and along with that I will upload this as well. Just to go through this and let me know if you have any challenges or anything. Then Monday we will be starting with the MongoDB. Okay, that will be 1 day session, and then we will start with the cloud. In between, if you have any question from the previous thing, then just let me know. All good?
Yes, Anamika.
Okay, then I believe that it's okay. Fine, then let's meet on Monday. Have a good day, weekend. Bye.
Bye. Bye.